All right. So in section 2.5, implicit differentiation, this is when you are going to start seeing functions that have x's and y's mixed together. And when you have to find the derivative of something that has x's and y's mixed together, you have to use this process called implicit differentiation. You always assume that you are differentiating with respect to x. You can only do one variable at a time. So if you are trying to find the derivative with respect to x, that means you find the derivative like normal, like you would any other time. Like, what is the derivative of this first example, x squared? What is the derivative of x squared? It's 2x. You do it just like normal. But because there's y's in that, that's going to screw it up a little bit. But the good thing about it is that you're going to find the derivative as though it is an x, but you got to add a little step to it. That's what I'm talking about. I will add that step to it in just a minute here. All right, so let's go on to this example. X squared minus 2y cubed plus 4y equals 2, and your job is to find the derivative. So, you find the derivative of x squared. What is the derivative of x squared? It's 2x, so there's a 2x here. What is the derivative? Pretend for a moment that that was an x. You would say that the derivative of a negative 2y cubed is negative 6y squared, just like normal. But because it's not an x, you have to add this thing in here. And that thing just means that you are finding the derivative of y with respect to x. See the y on the top and the x on the bottom? That means you are finding the derivative of y with respect to x. So every time you find the derivative of a y, you have to add that right after it. And then I'll talk to you about what to do with it in just a minute. You have to, always. What is the derivative of 4y? The derivative of 4y is 4. But because you were finding the derivative with the y in it, again you have to add a dy over dx after it. What is the derivative of 2? The derivative of 2 is 0. There's no x there, there's no y there, so the derivative of 2 is 0. All right, now our job is we're trying to find the derivative of this thing with respect to x. So what we need to do is get this dy dx that we have going on here, we need to get that alone. So what we're going to do is factor it out and solve it just like it's a simple algebraic equation. Now the algebra in this case is going to be so easy in comparison to the algebra that you guys have been exposed to lately. The first thing that I need to do is get rid of this 2x. How do I get rid of 2 x's? Subtract it. So I subtract 2x from this side. They cancel out. I subtract 2 x's from this side. 0 minus 2x is negative 2x. Yes?
How did you do 0?
The derivative of 2. The derivative of 2 is 0. Yep, and here, take this too.
Thank you.
Yep. All right, so we got rid of the 2x, got rid of the 2x over here, so we have a negative 2x. All that's left is a negative 6y squared dy dx plus 4 dy dx. Everything stayed the same. Both of these terms contain a dy dx, so I take them out. Take out the dy dx, I put it out front. When I factor out a dy dx, I am left with a negative 6y squared plus 4. You okay with that? All right, we still have a negative 2x over here on the right-hand side. Remember, our job is to figure out what is dy dx. Well, right now, dy dx is being multiplied by negative 6y squared plus 4. How am I going to get rid of these two things being multiplied? You're going to divide. So you're going to divide this side by negative 6y squared plus 4. They cancel out. Divide the other side by negative 6y squared plus 4. So you are left with, this is all gone. All we have left is dy dx equals negative 2x over negative 6y squared plus 4. So this is the deal. You started with a function that had x's and y's in it. So now, remember when you find the derivative, it means you're finding the slope of a line that is tangent to this curve. Well, now you have a derivative that has x's and y's in it. So in order to calculate the slope, you have to put both an x and a y value into this to calculate the actual slope. So I put a little note over here. You need an x and a y to calculate the slope of this. I was going to say of this function. All right, so that's it. It's not horrible. Yeah.
Could you just?
So the dy dx is part of the answer? Sorry.
So can you just take the x's and make it the numerator, and take all the y's and make it a denominator, and just find the derivatives of it? Like you go back to the original equation.
Let's go back to the original equation. Oh, Joey.
Keep going.
Okay.
See all that? Can you just take that x squared, find the derivative of it, and then never mind. It's gonna be negative. Never mind. I'm sorry.
No, it's okay. I'm just you are my pattern guy. You're always looking for patterns like that. I never think like that. So they're gonna get more complicated than this. Like in fact, look at the next example. I shouldn't say complicated. This is the what are we gonna use here, you guys?
Product rule.
Product rule. Not hard. Don't freak out on me. But we are gonna use a product rule, and when you use the product rule, I think your pattern there is probably not gonna work. All right, so xy squared equals 1, find the derivative, you have to use the product rule. Product rule says you take the first function, which in this case is x, and you multiply it by the derivative of the second. What's the derivative of y squared?
2y.
2y. What is the y? So what do I put next to it?
dy.
dx over dy.
dy over dx. The derivative of y with respect to x. All right, plus. Now you take the second function, which is y squared. Do I put dy dx next to it?
No.
Did I find the derivative of it? No. Don't use dy dx unless you are finding the derivative. So it's plus, not d, plus y squared multiplied by the derivative of x. What's the derivative of x? It's 1 equals, what, do I put a dy dx next to this?
No.
No, because I'm finding the derivative of an x, not a y. What's the derivative of 1? Which is 0. Get dy dx alone. So what we need to do is get this thing right here alone. So that means I need to move over the plus y squared times 1. How am I going to move plus y squared times 1 to the other side? Subtract it. So you subtract y squared, those cancel out. If I subtract y squared from the left, I have to subtract y squared from the right. So you are left with x times 2y is 2xy. dy dx, I just changed my x and my y around there. dy dx, okay. Is equal to negative y squared. Where'd the what come from? This two right here. Yeah. All right, so now we're going to divide by 2xy. They cancel out. Divide the right side by 2xy also. So we are left with dy dx is equal to, what can I do here to clean this up? Yeah, I can get rid of the y's, get rid of a y on the top and a y on the bottom. All right, so that's going to leave me with negative y over, what's on the bottom? 2x. That is my derivative. I have one more example to show you with one extra step at the end. It's not a hard step. All right, find the slope of y cubed plus y squared minus 5y minus x squared equals negative 4. So here we go. What is, I'll scroll up a little bit more. What is the derivative of y cubed?
3y.
3y. 3y squared. Yeah? So we have 3y squared, but what do I put next to it?
dy.
dy dx plus y squared. What's the derivative of y squared? 2y.
Why are you finding the derivative right now? Like, how do you know? Is it?
Well, it says to find the slope, and the slope means that you need to find, that's what the derivative is, it's the slope of the tangent line. So find the slope at, we're finding the slope of that curve at this point, okay? Plus 2y dy dx minus 5 dy dx minus x squared is equal to, no, excuse me, thank you, minus 2x is equal to 0. And I did not put dy dx next to negative 2x because it wasn't a y. Alright, clean it up a little bit now. I'm going to move the minus 2x to the other side. So I'm going to add 2. Slow down?
Yeah.
I guess. Add 2x to the other side. I have 3y squared dy dx plus 2y dy dx minus 5 dy dx is equal to a positive 2x. Okay, take a dy dx out. Am I alright, Larissa? Is that a no?
I don't get what you did from the first step.
From this step right here to this step? Okay, I left the dy dx's alone, and I get rid of the minus 2x. I move that to the other side because it doesn't have a dy dx with it.
Okay.
Now, all three terms that are left, I'll have a dy dx in it. So I'm going to take a dy dx out of it now, factor it out, and it's going to leave me with the coefficients of the dy dx's. So we're going to have a 3y squared plus 2y minus 5 is equal to 2x.
Okay, so is there ever gonna be a time when there's gonna be a number without dy dx? Is that only gonna be one?
Is there ever going to be numbers that don't have a dy dx?
You said, you know how you said the reason why we moved it over, the 2x over, is
Yeah.
because it doesn't have a dy dx?
Yep.
Is there ever gonna be multiple?
Oh yeah, there definitely could be. Yeah, there could have been. In fact, didn't the last example have that, or did it? I can't remember. It didn't have that. Hey guys, please don't do this. Yeah, there will definitely be times when you're adding or subtracting multiple things from the other side. Yep. Yeah. All right, now we have to solve for dy dx, which means we need to divide by 3y squared plus 2y minus 5, which means those cancel out. Leaves me with dy dx is equal to, but if I divide the left by that thing, I need to divide the right by all of this. So now I need to divide by 3y squared plus 2y minus 5. But we're not done yet because the directions told you guys to find the slope at the point 1, negative 3. The 1 is an x, the negative 3 is a y. So you take your derivative and you replace the x's and the y's with 1 and negative 3. So the x is 1. So we have 2 times 1 over. So we have 3 times negative 3 squared. So we have 3 times negative 3 squared plus 2 times negative 3 minus 5. So the top is a 2. The bottom, negative 3 squared is 9 times 3 is 27 plus a negative 6. So 27 minus 6 is 21 minus 5 is 16. So we have 2/16. What is that?
1/8.
1/8. So the slope, whatever this crazy curve looks like, whatever this thing looks like, if you go to the point 1, -3 on that curve, the slope is 1/8. Okay. Now, this is what you need to do tomorrow and the next day. And I have stuff for you to do, and I will do my best. I have a lot of stuff I got to get organized between now and when I'm gone tomorrow morning. But I will do my best to get all the answer keys posted, also posted on my website. So obviously, please make sure that you're using your time the way you're supposed to. I actually will post your first assignment that has to do with assignment 2.51 also. So after the homework copy, if you have a few minutes, you can start working on it. Today's assignment, the first assignment has 6 problems on it. They're all like this. They're not horrible. I think you're going to enjoy it, maybe.